Alrighty. So this is part of the assessment 2.2 review. I understand that as I record this, the students for algebra class have actually already taken assessment 2.2, and we're prepping for assessment 2.3. But there was a request to be able to check some answers or be able to go over some more of the work, and yeah, just go about it that way. So that's what we're going to be doing today. We're going to be going over some evaluation functions, and then we're also going to be going over some rate and decay functions, some rate and decay reviews. The idea is that we need to be able to spot what the rate and the decay are, and we need to be able to calculate it and say, well, based on this equation, this is the rate of decay or growth. Based on that equation, this is the rate of decay or growth, etc. Um, and so it's an important skill to have moving forward, especially moving into this next unit. Hang on, switching off lights. There we go. Especially moving forward into this next unit. I've got some background lights that I'm using, so hopefully this won't show up and be too weird. All right. So the good news about all of these evaluations, the good news about all these evaluation functions is that they are like you don't even have to think about them. You don't even have to work on them. You don't even have to think about them. You don't have to worry about them. All you're doing is you are feeding the functions, you are feeding the equations into your calculator exactly as you read them. And I'm not exaggerating. The way that you read it left to right, that's the way that you're going to put it into the calculator going left to right. I think I'm telling the truth. All right, let's do 3 times 2. We're doing this first one here. 3 times 2. I'm going to use the little up caret here, and it goes up to the x. The way the function notation works is if you have a function, if you have f of x and it gives you this function here, that means that everywhere there's an x, it means that everywhere there's an x on this side, you substitute in this the value that's in this like bracket area here. It's basically saying that if you have, so yeah, I mean that's pretty much it. There really isn't a lot of complicated. There isn't really much complicated to it. So it means that for this function here, everywhere that there's an x, you put a 4. That's pretty much all it means. And so going back to my calculator here, I've got 3 times 2, and it says find f of 4. So that means I'm going to hit 4. Hit a little harder. There we go. 3 times 2 to the 4th power. That gives me 48, which is the correct answer. I'm going to see if I can position these so that we can read the... I think this will work. Come on. There we go. Yeah, I think this will work. Which is the correct answer. Now, I'm just going to do number 2, and I'm just going to put it through. I'm going to read it left to right. I'm just going to put it into the calculator as I read it. 5 times 0.5 up caret. This is where the x would be, but instead I'm going to solve for 3. 0.625. Alrighty. It is this direct. It is this straightforward, and you are going to have access to this kind of calculator on the different assessments. So I've got 10 times 1.1 up caret x, but instead of x, it's going to be 2. There we go. Equals 12.1. All right. For number 4, I've got 7 times 0.8 up caret, and instead of x, I'm going to put in 5. Okay. Looks like 2.29. So this one's actually pretty interesting because I don't even need a calculator to know exactly what the answer is. The reason I know that is because it's going to be 2 times 3 raised to whatever power it is. But the thing is, the power that we're feeding in is 0. If you feed in the 0 power to anything at all, it turns it into 1. Just the number 1. It doesn't turn it into 1 over 3, doesn't turn it into 1.0, doesn't turn it into 0.1, doesn't turn it into 5.1, and nothing. All it does is it turns it into 1. It turns the entire term that is attached to that exponent into 1. So I'm going to slide these up here a bit just turns it into 1. So what does that mean? At f of 0, this becomes 1. I can cross it out and say that this is now 1. Well, what's 2 times 1? There we go. So anytime you see f of 0, so anytime you're solving for something that says f of 0, and it's a function like this, just put in the initial value, you'll be in good shape. All right, moving on. I've got 4, here we go. I've got 4 times 1.25 raised to the x power, but instead of x, I'm going to put in 3. That gives me 7.81. All right. Moving on to the next one, I've got 6 times 0.6 up caret x. Instead, I'm going to put in 2 instead of, I'm going to put 2 in instead of x, 2.16. All right. Then I've got, for the next one, I mean, these are all correct answers. These are all the right answers for the solution. This is how easy evaluating these functions are because it's all just calculator work. It's all putting it into the calculator and letting it do the heavy lifting, which is what it was designed for. So that means I got 1.5 times 2.5 raised to the x power, but instead I'm going to use 1, so that gives me 3.75. All right. Next one, I've got 9 times 0.9 raised to the x power, but instead of x, I'm going to put in 4. All right, that gives me 5.90. And I'm using 2 decimal points. You don't have to. That's just my, wait, there we go. All right, there we are. I'm just using 2 decimal points out of habit. You can use however many you want to or however many you feel comfortable with. There's no real hard requirement for it at this stage. So again, we have our very last one, 8 times 1.05 up caret to the x, but we're not using x, we're instead using 2, gives us 8.82. And those are all your correct answers for the first part of this assessment 2 review. These are all the correct answers. So what's next? I mean, when we're doing an assessment review, what could possibly be the next thing that okay. So we have to find the rate of growth or decay. I passed out a worksheet a while ago where we talked about the different ways that you can start with whatever number you have inside the parentheses and end with a rate of growth or decay. The answer is, the procedure was whatever the number inside the parentheses is. I'm going to move this all over here where I've got some space. Whatever that number is, we're just going to call it n. There we go. Now you can see it. We're just going to call it n. The procedure that we laid out, the process that we laid out, the foolproof method that we laid out was whatever n was, you're going to subtract 1.00 from it. It doesn't matter what it is. So if it's going to be, if n represents growth, then n minus 1.00 is going to be a positive number. It's going to be a positive number. And whatever that positive number is, we put directly into the parentheses. All right, that makes sense. If n minus 1.00, if n is less than 1.00, then that means we're going to get a negative number. All that means is we take the negative number, we make it positive, and we put that into the parentheses. So I guess if I wanted to write a real formula for it, I would say the absolute value of n minus 1.00 equals the number that we put into the equation. So, well, I guess I just kind of discovered that right now. So let's see how that tests out. I'm going to move this, slide this up, get it a little bit more oriented for the camera. There we go. So 100 equals b. Yeah, we'll keep that on. We'll keep that on there. All right. So 1.3. Whenever we're dealing with growth or decay rates, the initial values mean absolutely nothing. If we're just looking for rate of growth or decay, the initial values are just meant to throw you off. They're just meant to keep you busy. So I've got the value inside the parentheses, 1.3. minus 1.0. Take the absolute value of that, and that's going to equal 0.3. Well, 0.3, whatever that number, okay, do a little bit of an addendum to this. Whatever that number is, that'll give you B. Whatever that number is, it's not going to give you B. I apologize, I threw that one off. Whatever that number is, I'm going to say it's M. You take M, multiply it by 100%, and that equals your percentage. There we go. So take the absolute value of n minus 1.00, that's going to give you a number. You take that number times 100%, that gives you your percentage of growth or decay. So bringing this back to this problem, I've got 0.3 times 100%. That means that I've got 30% growth, which I do. All right. Ooh, it looks like we've got a good one here. So we've got 0.7. Again, the initial value means absolutely nothing in the context of solving for growth or decay. So I'm going to take the absolute value of 0.7 minus 1.0. That's going to give me 0.3. Now I know it's going to be a decay because this number is less than 1. But I'm still going to multiply this through times 100%. And that gives me 30% decay, which is the correct answer. All right, yeah, I think I got this worked out here. So 1.15 minus 1.0 equals 0.15 times 100% equals 15%. And because this number is greater than 1 or 1.00, that means that it's growth. All right. So this next one, I've got 0.9. It's less than 1, so I know whatever I'm solving for, it's going to be a decay. So 0.9 minus 1.0 equals 0.1 times 100% equals 10% decay. Oh, I'm going to be getting pretty good at this. And again, it's all just using this formula, this two-step formula. Whatever is inside the parentheses, subtract 1 and take the absolute value, that'll give you M. Whatever M is, multiply it by 100%, and that gives you your percentage for an answer. So let's keep the good times rolling. I've got 1.02 minus 1.0. That gives me 0.02 times 100% equals 2% growth. And again, I know it's growth because this number is greater than 1. So this number is less than 1, so I know whatever I'm calculating, it's going to be a decay. That gives me 0.6 minus 1.00. The absolute value of it gives me 0.4. Multiply that by 100%. And that gives me 40% decay. Decay. There we go. Got a couple more, and then we'll call it good for this worksheet because we're out of problems for the worksheet. So I've got 1.5 inside the parentheses. If it's inside the parentheses, that means that it's going to be growth. So that means absolute value 1.5 minus 1.00 equals 0.5 times 100% equals 50% growth. All right. Just keeping the good times going. So I've got 10. So I've got 10. I was going to read out the function, but the thing is, the function doesn't matter. These initial values don't matter. The function doesn't matter. All that matters is what's inside the parentheses. So inside the parentheses, I've got 0.95. It's less than 1, so I know I'm dealing with the decay. But in the meantime, I've got 0.95 minus 1.00. That gives me 0.05. Multiply that by 100%, and that equals 5% decay. Decay. Moving on to the next one. Again, I'm just looking at the parentheses here. 1.25, so I know I'm dealing with growth. Absolute value of 1.25 minus 1.00 equals 0.25. Multiply it by 100%, and that gives me 25% growth. So again, all I'm doing is I'm taking whatever the number is inside the parentheses, and I'm subtracting 1. Excuse me. Apologize for that. I'm taking the absolute value, so it's always going to be a positive number. I'm taking that positive number, multiplying it by 100%, and that gives me my percentage. All I have to do is figure out whether or not it's growth or decay. If it is greater than 1, it is growth. If it is less than 1, it is decay. So that's how I'm solving these equations. It's just a simple, it's a very basic, very direct procedure, we'll call it, that will give you the correct answer each time. So that moves us to 0.85. So I'm looking at 0.85. I know that it's less than 1, so that means I'm going to be dealing with a decay. However, how much of a decay? That's 1.00 equals 0.15 times 100% equals 15% decay. There we go, without any effort. So these are the answers to finding the rate of growth or decay. And if you zoom the video back, you can find out how I got the answers here. I'll give you a hint. The calculator did most of the work. And so again, this is assessment 2.2 review. Most of the folks that did evaluate the functions did it pretty well. Finding the rate of growth or decay is hit or miss, but most people are able to do that pretty well too. Anyway, it never hurts to practice, and it never hurts to continue moving forward.